transformations of logarithmic functions. So we're just taking a look of how the graph of y equals log of x, this is the common log, how is it transformed by these functions here? So the basic function is log x, and now we've added 3 to x inside the function. Remember, if a change occurs inside the function, it's horizontal. And if it occurs outside the function, it's vertical. So this is a horizontal shift to the left by 3 units. So we're going to shift the graph by 3 units. Here we're going to shift to the right because it's inside, we're subtracting 2 inside, and then we're going to shift up 4 units. So here we're shifting to the right by 2, and then to the left, I'm sorry, not left, up by 4. Okay, here we're multiplying by a factor of 2 on the outside, so this is a vertical stretch. And here inside, we're multiplying by negative, so that's going to be a horizontal reflection, in other words, across the y-axis. So this function here is reflected across the y-axis. So let's just take a look at Desmos and see how these functions look. So let's take y equals log of x, that's the common log, and there's our graph. And now we're going to look at y equals log of x plus 3. And you can see the best way to do this when you're looking at these is to notice how the vertical asymptote is shifted. So here's the vertical asymptote for the red function, which is the basic log function, basic common log function. And now that asymptote has been shifted over 3 units to y equals minus, I'm sorry, x equals minus 3 is our asymptote. Asymptotes are always in the form x equals a constant. So you can see the asymptote here is the line x equal minus 3. And if you zoom in, it gets closer and closer, but never touches. So that's an asymptote. And then if we take our original function log x and multiply it by minus x on the inside of the function, you can see it gets reflected across the y-axis, as we would expect. If we take x and subtract 2 on the inside, it gets shifted horizontally to the right by 2 units, and then up 4 units for the 4 on the outside. So you can see the effect that these translations have on our log function. And if you want to see a vertical stretch, we'll just multiply by 2, y equals 2 log of x. And you can see the red is the original and the black one just gets stretched up. This point here on the x-axis stays fixed because the output is 0, and when you multiply 0 by 2, it's not going to change, it's still 0. So this point doesn't change, but everything else gets stretched by a factor of 2. Here, this point is doubled to this height here. and so on and so forth.